has to be zero shearing stress, because the material that they test has zero shearing stress. Then you can select the what? Then it's time to do real engineering work. Okay. Okay, this is what it's all about. Okay, this is what it's all about. Okay, real engineering work. So what I've just mentioned to you, it will take me 3 weeks to teach. And this is week number 1. But you have done the difficult part. What is the difficult part? You have done the difficult part. What is the difficult part? The difficult part is this. Yes, you know how to do this now. And this, you also know how to do that. These two are the difficult part. Okay, now we have to assemble all together. If not, I'm wasting your time. Okay. So now we are going to analyze the structure. Okay. So you have this image with you. Okay. You have this. So we're going to determine the stresses acting. So example. So I'm going to teach you by doing this example. Okay. It's very procedure based. Okay. And I believe you will enjoy it. Okay. If you follow the procedure that I teach you, it's easier. Okay. Now the solution manual will come out with different forms of solving it. Don't use, only use their final results. Use the technique that I teach you. Okay. So we are going to determine. Yes.
Can you please go to the previous page quickly? I missed something.
Yes.
Perfect, thanks.
Excuse me, Eugene?
Hold on. Someone face to face is asking questions or so on. Yes.
Let's just say maybe like in real life, right? And have some sort of a structure that we need to design or find stresses at. In here, you have given the elements.
Yeah.
How would you determine in real life where would you look at the?
So the element, good question. How do you know where to locate the element? The location of the element is where you have to guess where the structure is going to fail. This table over here, right? If you look at this table, where is it going to fail? Is it going to fail at the center? The answer is no. It's going to fail at the joint, right? No point calculating stresses that is not the maximum. Okay, you have to calculate stresses where it's the maximum. Yeah, all this thing that we teach is we give you the structure, find element H, find element K. What if the question don't ask you to find element H and K? You find where the element H and K is. Yes. So now we are still teaching. Okay. Later on is where your guess where the failure is. Okay. Yes. Jiang, you have question.
Yeah, I think the shear stress A is larger than the 1, right? It's on the right hand side of shear. Or can you please just explain again why is the shear stress A smaller?
Shear stress what?
The shear stress A
is smaller than shear stress 1?
Yeah.
Yeah, because this is a material property. Right? This is your what? Calculated stress. So your calculated stress has to be less than stress 1. Chiang, does that make sense?
Is that the answer for sorry,
Why it has to be smaller, right?
Oh, okay.
Yeah, so what you calculated has to be less than the material property. It's higher than the material property, we're going to have some trouble, okay?
Oh, okay. Okay, thanks.
Okay. Okay, we are going to analyze this structure now, okay? We are going to determine the stresses at element H and element K. Okay. So we are going to calculate this. Okay. So first of all, I'm going to teach you a list of procedure, and just follow this procedure. Okay. It is not difficult at all. Okay. So we are going to first of all, we are going to identify we're going to identify the moments Okay, so for this case, moment is about y in z-axis. Later on, I'll teach you how to identify them. We have to also identify the axial force, which is your px. We also have to identify the shearing stress or the shear force, which is your Vy and Pz. And we also have to identify the torque, which is Tx. Okay? We have to identify all these things. So first thing of all, okay, number one, identify the transformation. Okay, so the transformation over here is given to us. Okay, so this is our x, this is our y, and this is our z. Okay, then the next thing that we have to do is we have to locate locate the centroid. Okay, locate the centroid axis relative to elements H and K. Okay. So what do I mean locate the centroid? So we can see where element H and K is, yes or no? You know that this is your element H and this is your element K. So the centroid relative to element H and K is over here. Okay, so this is our centroid. You always have to locate your centroid. Okay, so the centroid is not for the whole structure, yeah? It's not for the entire structure. It's only for element H and element K. Element H and K are the element of interest. Okay, then the next thing that we're going to do, okay, or the next thing,
So
yeah.
what if say element K was on the vertical portion
Say
of,
it again.
what if element K was on the vertical portion of the structure?
So if the element K is on the vertical, then okay, then this is the centroid. Are we clear?
So two centroids?
No, you change the question for me, you cheeky sort. You ask me why the structure is on the vertical, then you are telling me there's two centroid.
Let me clarify. What if element H was on the horizontal piece and element K was on the vertical piece?
Oh my God. So let's say this is your element W.
Right.
Okay, so this is the centroid for element W. Does that make sense?
Yes. So two centroids.
I think it's confusing.
Oi! Para. If it's just element W, you use that centroid for element W. It's for element H and K, use the horizontal or use the x-axis centroid. Is that clear?
Yep. Yeah.
Hello?
Yes, clear.
Huh?
Yeah, yeah.
Yeah, you're clear? Very good. Ay, 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 ay. I will tell you something about that student Opara, okay? I'll tell you this now. Term test 1, he barely make it. Term test 2, he got 17.5 out of 20. Okay? I think he's very hardworking. Opara, can you hear that? He's acting dumb now. He did not hear it, you know.
I can hear you. I can hear you.
You can hear me, yeah? Go celebrate, you cheeky sort. Okay. So number 3 is do not analyze the forces that are dots and crosses. Opara, don't ask any question yet, okay? Let me go further, okay? Okay? So that's what we're going to do. So the next thing we do is we're going to draw the structure based on a 2D view. I repeat again, we are going to draw the structure based on a 2D view. Okay, so we're going to sketch now. Okay, I'm going to copy this image so everyone can see. So the first view that I want to see, that we want to analyze, is we will analyze this in the XY view. Okay, and that's the case. This is our rotation about the Z. Okay, so we're going to sketch that now. Okay, we're going to sketch. So this is my sketch. So this is okay, so this is our sketch. Okay. So then we have a vertical part. Again, this is just a sketch. Okay. So over here, what can we see? Right? So we can see the 150 pound. Then the 200 pounds is going to come towards us. It's a dot. Then we have a cross of 50 pounds. And then over here, we have another cross of 150 pounds. Okay. Then we construct our element H and element K. Okay. We do this first. Oh, H on top. H on top and K, yeah? Okay. Then from here, we draw the same what? We draw the same. What color is this? No, this is not the color I want. We draw the same centroid. Okay, we draw the same centroid. The centroid is very important. So rule number 3 says, right, do not analyze the force that are the cross